And may I invite Richard to begin our event?
Okay, thanks, Michelle. So good evening and welcome to the second presentation of the 5-part webinar series. My name is Richard Witham and I'm the chair of the Greater Sudbury Watershed Alliance, and joining me on screen is Terry Rees, the executive director of the Federation of Ontario Cottagers Associations, Bree Edwards from the Valley Living with Lakes Centre, and Dr. Norman Yan, our speaker for this evening. The Greater Sudbury Watershed Alliance recognizes the ancestral land on which we live and work as the traditional territory of the Ojibwe, Odawa, Potawatomi, Algonquin, and Métis peoples. This territory is covered by the treaties of Robertson-Huron, Manitoulin Island, and Treaty 9, with Wikwemikong remaining unceded. We offer our gratitude to the First Nations for their protection of and teachings about our earth and our relations. May we honor these teachings. We're recording all the webinars, and links to the recordings will be posted on our respective websites so that those of you who are unable to join us this evening, and anyone else for that matter, will still be able to view the presentations. The Greater Sudbury Watershed Alliance acts to promote, protect, advocate for improvements in water quality and healthy watersheds. We have representation from 23 lake and creek stewardships and 2 First Nations. And although much of our focus is on the protection of local watersheds, we also respond to municipal and provincial government activities that reduce environmental protection and increase risk to aquatic environments. We're very grateful to have partnered with the Federation of Ontario Cottagers Associations and with Valley Living with Lakes Centre in the presentation of the Troubled Water webinar series. All 3 organizations have worked very hard on the development, promotion, and delivery of this event. We're also indebted to the additional organizations and individuals who have helped promote this series, resulting in local, cross-Canada, US, and international registrations, but we would like to get an idea of where the attendees for this session are located. So you'll see a poll, if you wouldn't mind just choosing the choice that best represents you.
And we're getting lots of responses. We'll just wait for a moment, as it does take a minute for that information to come in, and then we'll share what we've learned. So it looks like we have about 50% of our attendees from the Greater Sudbury area, 40% south of Sudbury, a few in areas north or northwest of Sudbury, and some others from elsewhere in Canada outside of Ontario.
Thanks, Michelle. All right, so over to you, Terry.
Thanks, Richard. As Richard said, my name is Terry Rees. I'm the executive director with the Federation of Ontario Cottagers Associations, and FOCA is pleased to be co-hosting the series along with the Greater Sudbury Watershed Alliance and the Valley Living with Lakes Centre. FOCA is an Ontario not-for-profit organization with over 500 member associations across the province, and we represent the interests of Ontario's 250,000 waterfront property owners on issues that matter most to our communities and to our families. We compile a great deal of our information on our website at foca.on.ca, so I encourage you to visit there to answer all of your vexing questions about waterfront living. And if you haven't signed up for our FOCA alert, it is an e-newsletter that we distribute monthly to many people across the province with topical information. I'd like to take this opportunity to thank the over 600 volunteers that participate in the Ontario Lake Partner Program every year. It's a long-standing partnership between FOCA and the Ministry of Environment, Conservation and Parks, and it provides valuable data that informs many of the questions and research that you'll be hearing about during these webinars. For almost 60 years, FOCA's members have identified water quality as their #1 concern and interest, and COVID or not, our freshwater systems, and that's the lakes and the watersheds that feed them, they face many challenges and threats. We believe through understanding these complex systems more thoroughly, we can build our appreciation for their dynamic nature and ultimately build a stewardship ethic so that together we can keep our lakes great. We're blessed with an abundance of wonderful fresh water in Ontario and also with a lot of thought leadership about freshwater, including tonight's speaker, Dr. Norm Yan. I've been asked to talk about some logistics about the Zoom platform. You're all muted to reduce the sound disruption during the presentation. If you experience any technical difficulties, your sound goes funky, your audio doesn't work, or your video, we're encouraging you to just get off of the Zoom and try to re-enter. If you have a problem re-entering, as we've mentioned, you can get on the YouTube channel through the FOCA YouTube page. We'll be taking questions through the Q&A. So if you see the Q&A button on your screen, you can enter your questions at any time, and we'll be asking those questions of our speaker at the very end. If you don't see the Q&A button, you may need to tap on an iDevice, or look for the button, or look for the three dots where it says more. And please ask your questions as they occur to you, and we'll ask them at the end, as I mentioned. Thanks for attending tonight. We hope you enjoy the presentation. Stay safe and be well. And I'd like to hand it over to Bree Edwards.
Awesome, thanks, Terry. I'm Bree Edwards. I am a research scientist with the Ontario Ministry of the Environment, Conservation and Parks. And I am lucky enough to call the Living with Lakes Centre my research home. So the Living with Lakes Centre is a beautiful state-of-the-art facility that's located on Laurentian University campus and the shores of Ramsey Lake. And what's really special about the Lake Centre is that it houses the Cooperative Freshwater Ecology Unit. And so this unit is a long-term and really unique partnership in research and collaboration for all things reclamation and aquatic science in the boreal inland lakes. And it sort of partners universities, including Laurentian and others, with government agencies such as the one I work with, and federal partners, as well as industry and stakeholder supporters. So tonight, I once again have the great pleasure of introducing a mentor and friend, Dr. Norman Yan. Norm is an emeritus professor at York University who spent the first 25 years of his career in a role similar to my own as a research scientist with the Ministry of the Environment. Norman was one of the early powerhouses behind both the Cooperative Freshwater Ecology Unit and the Dorset Environmental Science Centre. And his publication record is a testament to his incredible ability to bring people together to tackle big questions in our fields and for inland lakes and streams. Similar to Dr. Gunn, who was our speaker from last week, Norman's first focus was on the chemical and biological impacts of acid and metal pollution and what could be done to promote and monitor recovery. Norman's research has also been critical in the discovery of calcium decline, which is an after effect of acid pollution, and its interactions with other concurrent changes. He's a big part of the reason actually that I pursued a lot of the questions I did in my own graduate research, and his mentorship has done much to help me in pursuing my career in science, and I know so many others. Today, Norm is going to be sharing what's known about calcium decline and some exciting efforts aimed at bringing people together to find solutions. So without further ado, please welcome Dr. Norman Yan.
Well, thank you very much, Bree, for that wonderful introduction. Can you see the slides?
Yes, we can.
Okay. So from fireplace to pancakes. So to jump to the end, maple bushes are limited by widespread calcium decline. If you can solve the calcium decline problem, they'll grow bigger. Bigger maples produce more sap, and more sap produces more maple syrup. But please, everyone, stay on the line for details. Let me start by making a few acknowledgements, and you can read them here. Mainly to the Trillium Foundation for funding the work I'm going to be talking about, to now up over 700, close to 1,000 people who are hauling their ash, a calcium-rich substitute that I'm going to talk about, a number of academics, sugar bush operators, our volunteer board, the co-op unit that Bree just talked about for almost, in my case, 50 years of interactions, FOCA, the Greater Sudbury Watershed Alliance, and the Valley Living with Lakes Centre for the invitation to speak to you tonight. It's a pleasure. So as Bree mentioned, there was a time when I had dark hair, and that was in the early 1970s when I first arrived in Sudbury, almost 50 years ago. I showed up there in 1973, and by 1976, I was involved in the work that you're seeing in these left-hand pictures. These were the early days from 1973, 74, and 75 for those people in Sudbury that are my age, where we were adding lime using that technique you see in that boat to Middle and Hannah Lakes and to Lohe Lake. And 50 years later, we're still actually studying those lakes. And a few years after that, the lake liming programs began, shown in the picture on the right over here, in this grainy old picture, both published in John's book on restoration of an industrial landscape. And as Bree mentioned, the concern was getting rid of the acid problem and then tying up the metals and reducing the metals. There was no thought given particularly to the calcium itself. But as I am preparing the material for this talk, I have to say that many of those of you in Sudbury who've been involved one way or another in the lake or the land liming efforts will understand that much of what I'm going to talk about today was actually been inspired to some extent by these early days in Sudbury. Because there's really nowhere else on the planet where we've learned as much about adding alkaline materials to the landscape as we have in Sudbury. So turning away from acid and metals for a sec and just thinking about the calcium, it's essential to all living things. It moves through watersheds, cycles through watersheds, taken up by the trees, falling down in the leaves to the ground, recycled back up into the trees, but slowly moves downstream. So calcium levels can fall if there's a dramatic reduction in input from the atmosphere, or if the rate at which calcium is reintroduced to the soil by weathering of rock falls. So when the sources of calcium fall, it's possible to lose calcium either from the soil or from the water. And that has an impact on biota. I noticed there was about 220 people on the call. And if they are my age, it's a good guess that a bunch of people on this call have osteoporosis, because it actually affects 1.5 million people in Canada, a third of senior women, a fifth of senior men, 10% of people over the age of 40. So we all have a sense for what osteoporosis is. Something has gone wrong with our calcium uptake, our calcium loss, or our calcium metabolism, and our bones are brittle as a result. So let's ask the question if there can be kind of an analog of osteoporosis in landscapes. Can watersheds and the plants and animals they support suffer from kind of an analogous ecological osteoporosis? And I would suggest the answer is yes, if species that need a lot of calcium don't get enough calcium in their environment to supply their needs. Now, you and I are about 6% calcium on a dry weight basis, but there are animals in lakes that need a lot more calcium than that. And it won't surprise you that it's the crusty animals like crayfish, or the crusty animals, shelled animals like snails, the shelled animals like turtles with their rib cage that's turned into a shell. Even fish, while they're supported by the water, can have more calcium than us. Trout are only 2% calcium, but bass are about 8% calcium. If you've heard me speak before, you know I often talk about water fleas like this little Daphnia. They can be up to about 8% calcium. And so there's lots of creatures out there need calcium. That's requisite number one for ecological osteoporosis. The second requisite is that calcium supplies in the environment fall. So let's start by looking at that question in Sudbury, pulling a paper that Bill and Jocelyn Hedeberry and Bree from this phone call authored in 2018. There's 42 lakes in Sudbury that are have been sampled occasionally for many decades. And this upper plot shows the trend in changes per year in the pH. So all these numbers are positive. Rising pH indicates falling acidity. And I'm thrilled to see Clearwater Lake at the very end here, the lake in Sudbury that has the most rapidly increasing trend of pH. So the pH has gone, I think, from about 4 to close to 7 over the last 30 years or so. That is the wonderful restoration story that we talk about in Sudbury, where dramatic reductions in emissions coupled with lots of addition of lime to landscapes has allowed, but mainly reduction in emissions, has allowed a reduction in acidity or recovery in pH. Hand in hand with that, though, has been a dramatic decline in calcium. Notice that every one of these trends is negative. And here's poor Clearwater Lake, second from the worst, if you want, in terms of the rapidity of decline in calcium over the years. Now, in part, this is completely natural and completely expected and implies only that acid is stripping calcium from the land at a slower rate. So there's less calcium input into these lakes, so calcium levels inevitably fall. Where it becomes a problem if calcium levels fall to levels below where they were historically, and if they fall to a point where the calcium-rich animals start suffering. So let's turn our attention 3 hours down the road from Sudbury, southeast into the Muskoka area where I live. And I'll thank Andrew Patterson, one of Bree's colleagues from the Ministry of the Environment, who've been sampling a number of small headwater lakes every 2 weeks to month, going on, well, since the late 70s with methods stabilizing in the 80s. So over this period of 35 years, there's been on average a 35% reduction in calcium levels in these lakes. But more importantly, in half of the lakes, the calcium is now less than 1.5 milligrams per liter. And that's a level at which calcium-rich animals start dying. And this is not restricted just to those 7 lakes that the Ministry of the Environment happened to pick in the late 70s for long-term work. It's quite common in the whole area. So for here you are up here in Sudbury, come down the road to roughly this area right here, and you're in this watershed, which has 1,600 lakes. Here is that watershed expanded. Notice all the red dots. We actually have measured calcium data from close to 600 of these 1,600 lakes. The red dots have calcium levels less than 2 milligrams per liter, the point at which Bree's favorite animals, the crayfish, start suffering, certainly in this area. And so for half of the lakes in the Muskoka watershed now have calcium levels low enough that we should start worrying about the health and survival of calcium-rich animals. And that is actually characteristic of pretty well the whole province. So this paper led by Adam Jazorski, who just left my lab and was just starting his PhD in John Small's lab. It's nice when your very first paper out of your PhD is published in Science. And what Adam did is gathered data from northwestern Ontario, north of Sault Ste. Marie, a couple of data sets in Sudbury, and a couple of data sets in Muskoka. And I want you just to look at the orange and red bars on the right of each plot, and notice in every case that there's more orange and red in the second plot than in the first plot. And that's from the 1980s over the next 25 years. And in my area in Muskoka, in the small lakes, 80% of the lakes actually had calcium less than 2 milligrams per liter. So especially in the small lakes in Muskoka, a huge number of the lakes are suffering from calcium decline, but it's quite a common problem across Ontario. In fact, it's quite a common problem in Eastern North America and Western Europe, in areas with thin soils produced from granite, lying over granite that suffered decades of acid rain. This is actually a common problem. So why is it happening? Well, it's happening in part because calcium levels in soils in the watersheds have declined. Calcium levels have actually fallen in atmospheric deposition, but that's as well, but that's actually generally a small component of the total calcium budget. Let's ask this question, which for limnologists like me is a new one. If there are enormous differences in calcium requirements between animals in the water, might there also be differences in calcium requirements in plants on the land? And the answer is yes. Here's calcium levels, for example, in the wood of maple and birch and a conifer, differing by 5-fold, as you see, between species. Calcium levels in the bark differing by 10-fold, and calcium levels in the leaves, where they have only physiologic functions, differing by 2-fold. If there was a crayfish on the land that might be most suffering from calcium decline, it is the sugar maple. And in fact, there's widespread dieback of sugar maple forests of eastern North America. And the most common explanation for that is falling calcium levels. How much have calcium levels fallen? This is unpublished, so I thank Sean Motwa's group from letting me show you this graph. This is modeled results of calcium loss from a forest under sugar maple east of where I live in Halliburton. And their estimate is calcium levels have fallen from around 1,400 kilograms per hectare, about 1.4 tons per hectare, up until today to about 700 kilograms per hectare. So and most of the decline happened during the heyday of acid rain from the 1950s to the 1980s. This forest losing, the model suggests, roughly 50% of its calcium, a little more than half a ton per hectare. What do the measured data from soils show? The Air Resources Branch of the Ministry of the Environment, starting in the 1980s, visited about 4,000 hectare plots scattered around central and southern Ontario. And every year they went up to these plots. They measured the chemistry of the soil, the chemistry of the leaves. They assessed the health of the forest. And between 1985 and 2005, documented a 60% decline on average in calcium levels in surface soils. And that was associated with an 18% decline in calcium levels in leaves of sugar maple. And the forests that had lower leaf foliar calcium and lower forest floor calcium were unhealthy, independently judged by leaf dieback, annual growth, canopy openness, dead foliage, that kind of stuff. So the unhealthy forest had low forest floor calcium and lower leaf calcium. Now, why is that? You can kind of use an ATM analogy. The amount of calcium you have in the bank, in this case, the soil bank, is a function really of deposits and withdrawals. What did the glaciers leave there in the first place? What kind of rock underpins the soil? If there's calcareous material, there'll be lots of calcium. If there's no calcareous material, maybe not. Rainfall and dust can add calcium. For example, there was a big tornado in the town of Barrie in the early 80s. All of our rain collectors in Dorset filled up with dust from southern Ontario. That doesn't happen that often, but that was a big input of calcium from the south. Typically, calcium levels in the rain are actually falling these days. And then we do things. We add dust suppressants, calcium chloride. We might fertilize, or we might do something like add wood ash. And all of these sources can build the soil calcium bank, and that might be good for the lakes downstream. But there are other mechanisms which are withdrawing calcium from the soil. Trees, as you saw, grow, and trees are probably about 0.5% calcium on average, maybe 1%. Soils naturally age, and then we do things. We clear the land, we log, and then the forests grow back. And then we do the worst thing, which is acidify the atmosphere to levels 100 times more acidic than it should be, and we let that go on for half a century. So certainly the biggest driver for following calcium levels in the soil is acid rain, which stripped about 0.5 ton of calcium per hectare over large regions of Canada. So now let's enter the Friends of the Muskoka Watershed. I retired in 2014, but since then I've been working with this not-for-profit environmental group, the Friends of the Muskoka Watershed. It has a vision which I suspect the organizers of this webinar would be very happy with: healthy lakes forever. And we execute that vision by trying to generate the knowledge and will needed to fix environmental problems. So our stated purpose and our strategic plan is to work with the local and broader scientific communities to identify, develop, and foster solutions to watershed stressors in Muskoka. And I mentioned knowledge and will. I've been at this for almost 50 years or thereabouts. And I'm an optimist about the state of the environment. And I've come to believe as long as your democracy is functioning, it takes only time, because watersheds react fairly slowly on human timescale. Knowledge and will. You need to know what to do to fix the problem, and you need to have the will to do it. And the will to do it is often harder to generate than the knowledge. The rest of that you can see. I believe strongly that the core values that produce knowledge and will, respectively, are humility and hope, because only humble people are open-minded. And it takes an open mind to actually develop the knowledge to solve problems. Okay, so can I translate this idea of knowledge and will into an actual flow chart of our Ash Muskoka project? So we first, as I said, the Friends of the Muskoka Watershed keeps track of 10 to 20 potential environmental issues and a watershed threat that has 3 characteristics we get interested in. It's widespread, no one's looking after it, and the local community can help solve it. If it has those 3 characteristics, we get interested. Calcium has those characteristics. But then we need to know what to do to help solve the problem. And then usually we have to raise some money, because from this point on, we're going to probably strike applied research contracts with universities to try and generate the knowledge that we need so we can move on to the next stage, which is to foster the will among managers or policymakers to try and fix the problem. This is pretty simple in a way. How does it apply to what Ash Muskoka is doing with our calcium decline problem? Well, I hope I made it obvious that there is a problem with calcium decline in lakes, and that's linked to calcium decline in the forest. Half the lakes in Muskoka have calcium levels now low enough that crayfish are probably dying, for example. And it's because loss rates are higher than supply rates. We need some new sort of calcium supply, and because the local community might be able to help with that, it's a problem that our NGO is interested in. But we don't quite know what to do yet. We don't know how much calcium is in ash necessarily. We don't know how big a dose is actually needed. We don't know if all the calcium in the ash is available, and if it's not very available, we need a bigger dose. We don't know if we have enough ash. There may be risks. There's at least 11 toxic metals, potentially toxic metals in the ash. We're pretty sure there are benefits, but we haven't quantified them, particularly in hardwood forests growing on calcium-poor land. These are all kind of applied environmental science questions, but there's also kind of sociology or psychology questions. Is the public willing to share their ash with us? Are they willing to work to haul their ash from their fireplace to us? And then finally, what do we do with it? So these are the questions we kind of want to address. We were successful with getting 2 grants from the Ontario Trillium Foundation to allow us to strike applied research contracts with 3 universities to allow us to address these questions, both the sciencey ones and the more social sciencey ones. And after a few years of work, we hope we can answer those questions, and then we get into the trickier business of convincing policymakers and forest managers that there's something we can do about it. Okay, why do I think it should work? There was an amazing experiment done in the Hubbard Brook Experimental Forest, which suffered roughly the same amount of acid damage as we had. And they said, well, let's just add the calcium that got removed. And they did this with a solution of calcium silicate and see what happens. They added the calcium in 1999. Here's what happened to the leaf calcium. It went up by 2.5-fold over a couple of years. But the main thing I want to tell you is that the forest woke up. The soil pH went up, chlorophyll levels in the leaves went up, calcium levels went up. That's what's shown here. Photosynthesis went up because there was now enough calcium for the metabolism of the leaves to work properly. Transpiration went up. Transpiration actually went up by 20%. The stream actually dried up in the watershed for the first time on record. There was more calcium in the fine roots. Everything about the forest got better when they just corrected this calcium decline problem, proving that it really was low calcium that was responsible for the widespread dieback and, if you want, sleepiness of the forest. Now that was done with a calcium silicate solution, but we have a more direct example in Halliburton, east of us, done in Sean Watma's lab. And Nate Basilico was involved in this experiment as well, where calcium was added, ash was added from an industrial source at 2 levels, 4 tons or 8 tons per hectare in 2014. And 2 years later, calcium levels in the leaves had gone up by about 50% at both ash doses from below to above a threshold at which photosynthesis and growth of the trees was limited by calcium. And at the 8 ton per hectare dose, the actual wood accumulation rate of the trees increased by 100%. So what are we doing? In the spring of 2018, after receiving funding from the Trillium Foundation, the Ash Muskoka project began with 3 purposes that you can see here. Let me remind you, this is funded not by NSERG, but by OTF. OTF doesn't fund environmental science. They fund public community engagement for the public good. So what OTF really cares about is that we get hundreds of members of the public involved in ecological restoration. So that's our main goal. But to do it properly and launch this wood ash recycling program, there's some applied science that we have to do, and that was in that big yellow bubble, or listed again here. So we hope that we'll have a more environmentally engaged public, that we'll have healthier, more vigorous sugar bushes, and I hope to show that to you. And if they are healthier and more vigorous, they should be a little more resistant to climate change and windstorms. A calcium-limited tree is 30% weaker than a tree that is not calcium-limited, so wind damage should fall. If there's 50% more growth of accumulation of wood, that means more carbon capture. If there's more transpiration, that means the amount of water that's sitting on the landscape that we've seen in mixed hardwood dominated forests over the last 50 years is probably unnatural because the trees have not been pumping their normal amount of water. So there's probably a link to spring floods. And then ultimately, this all started with Daphne and crayfish brie, so I'm hoping we can end up with a little more calcium in the water downstream. Okay, there's a bunch of partners. I'm just listing them here quickly. The maple syrup producers were working in their sugar bushes. District government has helped with collection. The Dorset Environmental Science Center has been great, helping with analytical support and toxicological work in the first year. I'll talk about the universities in a second. A local museum, which has 30,000 visitors a year, is helping us educate the public. We're doing a big ash edition in the forest at an educational camp. And finally, we're hoping that Westwind Forest Stewardship will help us roll out this program more broadly. Let me tell you briefly what the 3 universities are doing. So we struck research contracts with Trent, with Laurentian, and with University of Victoria. We thank the Trillium Foundation for letting us spend Trillium money outside Ontario, which is unusual. So Dr. Watma is leading the work, I think so far with 4 graduate students on the environmental science. What are the benefits? What are the risks? How big are the doses? How available is the calcium in the ash? And what's happening with maple sap production? Brand new for me, I've never been an environmental psychologist, but if we're trying to foster will, we need to understand what the underpinnings of will. And so Bob Gifford is working with us. We're funding a postdoctoral fellow in his lab to understand the barriers to public participation in the project. And Dr. Barrio, who many of you will know, who runs the science communication, the wonderful master's or graduate program in science communication at Laurentian, provided us with an intern who made a wonderful video on the problem and ash as a solution. But the most important participants are hundreds of locals who burn firewood. Won't it be nice when we can get back to situations like this, where we can get together again? But hundreds of people are sharing their ash with us. I'll just also mention that we have a group of advisors, the Sugarbush community, the high schools, other lake associations, district government, Dorset, the media, that kind of thing. So we meet with these people twice a year for their advice. So let me kind of just show you how we're doing now. Early on, we did figure out there's enough calcium in the ash. So here are the levels of calcium, potassium, magnesium, sodium, and phosphorus in residential wood ash. Note how small the variation is. This was initially just based on 10 first ash suppliers. And the calcium levels range from about 27 to about 31%, which it starts to approach the calcium levels in limestone, which are 40%. But the advantage is you get these other nutrients in the ash. For those of you that are interested, we had one outlier, but not for calcium, but it was an outlier for the other minerals. And that outlier was the only ash provider that came from a wood-fired pizza bakery. So what we're picking up is the phosphorus and the magnesium and the potassium in the flour that was coating the pizzas that when they went into the oven. My most data-rich slide, so I apologize for it. Are there any risks? And the main risk the forest industry is concerned about is contaminants in the ash. So here we compare non-industrial wood ash, our residential ash, industrial wood ash from the AshNet database. And you need to know if there's a yellow box, then that level is higher than it's a potential concern to the ministry. If it's higher than the CM2 level, you can't use it. Then it's industrial waste. What you need to see is that our residential wood ash is a lot cleaner in terms of metals than the industrial wood ash. Sometimes remarkably cleaner, like 3 versus 300, for example. So we don't quite know why. The other thing to realize is that this ash will probably get cleaner over time because the atmosphere has lower levels of metals and it's not as acidic. So the wood that's being accumulated in the trees that are growing now is probably somewhat cleaner. So what we're doing is we're getting approvals to collect ash. We're collecting, transport, spreading it, determining doses, testing risks and benefits in replicated plots in the sugar bushes, and I'll show you that in a minute. Then scaling up and looking at the benefits in a more natural forest. That work has just begun. And then communicate. Is it working? We have over 700 people taking their ash for us. The women take the cans, the men take little pesky buckets, you'll notice here. That ash is brought to us at a transfer station. Here I am with staff and the deputy mayor with lots of buckets of ash. We screen it to take out coarse particulates, run magnets through it in case anyone used construction waste, and we get screws and nails. Many of you will know Neil Hutchinson. After it's been screened and homogenized, we carry it, in this case, in the fall of 2019 to sugar bushes. where we have lots of volunteers, including these three are graduate students from Trent University. We weigh it all out. And then we carry it into the bush and sprinkle it. So this is what 8 tons of ash per hectare looks like sitting on top of maple leaves. Now, has it done anything? Sorry, I'll just take a drink here. There's been a tremendous amount of sampling done by the graduate students, interrupted by COVID, so we're only starting to get the data now. But here are pH data, averaged from all 3 sugar bushes, from all replicates. There were 5 replicates, 3 treatments. The soil was sampled at 5 locations from each of 5 plots, from each of 3 treatments, from each of 3 sugar bushes at 3 depths. Those of you that know pH, there was a 100-fold reduction in acidity in the litter layer and the humus layer. And even though this doesn't look like much, at these pHs, this is actually a pretty dramatic change in acidity. So the wood ash has initially some of the same benefits as limestone. It's quite alkaline and it neutralizes acidity in the soil, but we're more interested in the calcium. Our preliminary work, based on work done again by another student in Sean's lab in one of the sugar bushes, showed a 50% increase in calcium levels in the leaves. So more calcium in the leaves, more photosynthesis, better functioning stoma, more transpiration, more carbohydrate production. 100% increase in the shoots, which means stronger stems, more wood eventually. Calcium plays the same structural role or an analogous structural role in plants as it does in our bones, strengthening the cells, and 175% increase in calcium levels in the roots within a year after the ash was added on top. So that had made its way up into the, either leaching into the soil or made its way up into the leaves, rained down in the fall, and then started to recycle into the soil. What might this mean? If we look at what happened in Hubbard Brook, more chlorophyll, more photosynthesis, more sugar production, stronger wood, more transpiration, improved crown health, etc. These are all of the features that increased calcium levels, the main limiting nutrient of plant growth should have for the wood, for the trees, and we'll have all the results of that within the next, I'm going to say 3 or 4 months. But the preliminary results are very suggestive and promising. These are 4 more of Sean's students working with us. We moved that into a larger natural forest at Camp Big Canoe, and in much larger plots that were 16 times the size. Last fall, we added ash at 6 tons per hectare. So what are we doing this year? This is presuming COVID allows us to do any of this. We're planning a 2 ton per hectare dose this spring. We lost half a ton per hectare of calcium over the last 100 years. The ash is 30% calcium. A 2 ton per hectare dose should supply all the calcium lost to acid rain. So we're hoping that the 2 ton per hectare dose is enough. That would allow our ash to go a lot further. We then should be in a position by next year to make the final selection between these 2, 4, 6, and 8 ton per hectare doses. But to scale this up, we're going to put a big effort this year into more kind of industrialization of the process, how to pelletize better, screen better, and then how to spread the ash mechanically, the way it's done in Scandinavia, for example, so we can learn from what others have done. We then prepare our final report with a little bit of extra new work. We didn't say we were going to work on carbon capture, and transpiration, but we're working hard to add those products to what we end up producing. We're also adding work on sap production, tapping trees actually next month in ashed and non-ash plots. And we're starting to negotiate with Western Forest Stewardship about rolling this out to the Crown Land Forests of Muskoka. Will we really end up with more maple syrup? The literature suggests that we should. If we get rid of the calcium limitation problem, the trees will put on more wood. Bigger trees produce more sap of the same sweetness. We should end up with more maple syrup, hence my title. Thank you very much for listening. You can see how all of my early work 50 years ago on liming of Sudbury lakes has never left me. Now we're doing something similar, but without having to mine the lime in the Muskoka area. And this should be applicable to the forests in the Sudbury area if you're willing to share your ash. I think I have a poll that we can launch at some point asking how many of you heat with wood? And if you do, how many of you would now be willing to share your firewood ashes with somebody that wants to restore their health of the forest, given that they're probably calcium limited? I thank you very much. I invite you to email us at ashmuskoka@fotmw.org and check out our website for updates on how we're doing on the ash project. Thank you very much. Do you heat or supplement with wood? I have to say that's an amazing statistic. The national statistic on people that heat with wood, according to Stats Canada, is 6%. So the fact that 70% of you heat with wood means, I guess I can only interest firewood burners in a talk like this, but that's wonderful to see. And that 80% of you that heat with wood would be willing to share your ash with us. That's fabulous. I'd love to, okay. Thank you very much. Okay, what's next, Bree?
Well, I'm going to be handling the questions. I'll give you a couple seconds to have another drink of water and catch your breath.
Okay.
I think what I'm going to do tonight is jump around a little bit in the list and try to keep things a little bit thematic before we move along. So we'll see how well I do with that. But you've got lots of great questions already. And of course, we encourage people to continue to ask questions as we start chatting. So we'll start with something kind of broad in general. How much calcium in the soil is natural, and does it differ in different areas, and therefore is more needed to fix problems in different areas?
Great question. Yes, there are enormous natural differences in calcium levels in the soil. If you have a soil that's been built from calcareous materials like limestone, as we have in Southern Ontario, there'll be very high levels of natural calcium in the soil. Those soils will not have been impacted by acid rain because there was a very, very large capacity of the soils to buffer acidity without losing all the calcium in the soil. Up north, north of Aurelia, say, the glaciers removed most of what soil was there. So the soil, as you all know, is typically 1.5 feet thick, maybe, or less. And it's been often built from calcium poor materials. So there is quite a difference. And then over millennia, depending on the plants that are there, this is me, a limnologist, talking as if I have a clue about what happens in the forest. There is a natural leaching of soils of calcium, especially if foliage produces quite an acid litter. And so Dr. Watma has estimated this, and depending on the trees that are growing on top of the soil, there may be actually more or less calcium lost in that soil over the tens to hundreds of years. And then higher higher in the watershed where soils are thinner and there might have been a little more rain or snow, there tends to be more calcium loss. And then the needs differ dramatically, as I said. So the hardwood, the mixed hardwood bushes of central Ontario and the same latitudes in Quebec need more calcium. The boreal forest needs a little less. And so as we move north and west from Sudbury and have less hardwoods and then much less acidity in the rain over the decades, there will have been much less calcium stripped out of the soil. That's kind of a wandering answer.
That's a great answer. When the ash is applied, does it get absorbed directly into the soil, or does it have, you know, a story to tell once it's dropped?
Yeah, there is. It kind of goes element by element. So the first thing I want to say is the ash is 1% phosphorus, but that phosphorus is not very available at all. It's apatite phosphorus. One of my early worries was we'd end up with lake eutrophication if we push this, because we were adding something to a whole landscape that was 1% phosphorus. So in the lab, and I thank the Dorset Environmental Science Center for this, we did a lot of leaching experiments, and we couldn't leach much of the phosphorus out of the ash. So we were actually reassured by that. Calcium is mainly in a carbonate form. There's some in an oxalate form, but it's mainly carbonate. And that's not particularly soluble. You can only get about 15 to 20 milligrams per liter of calcium before you hit saturation. And we consider that to be a good thing because it means every time it rains, we'll get a little bit more of the calcium out of that ash. And so it's kind of a slow release source. The only potential problem is the potassium. So the ash is 30% calcium, it's about 9% potassium, and all the potassium is soluble. So with the first rain, all that potassium will come out. And so if you add an enormous amount of ash around a very small pond, you can actually potentially get toxic levels of potassium in a short pulse. Because the work we did in the lab with Daphnia, I'll just tell you a little story. So the first technician that was working on the project, first scientist, we were testing the toxicity of the ash in slurries that were vastly more concentrated than we would ever get with a natural addition in the forest. And so I said to the tech, start with 10 to 1 of this slurry. That'll kill everything because the pH will be like 13. And so we can't expect anything to live with a pH of 13, but let's then do serial dilutions. And so she came back and said, oh, everything died. I said, yeah, I know it would die because the pH is 13. So now do it all again, drop the pH to 7, and hopefully everything will be okay. She did it again. She came back and said, all the animals died. So then suddenly I'm thinking, oh, okay, we're missing something. Well, it turns out what we were missing was potassium. All that potassium came out. And so we had I think it was 400 milligrams per liter of potassium in the concentrate, and that killed the animals. So my only concern is you wouldn't want a huge pile of ash just before a rainstorm sitting beside on the edges of a stream, because you could get so much potassium coming out that it might actually reach lethal levels in the short term. Practically, I can't see this ever being a problem the way we're spreading the ash, because we keep it a long way away from lakes. That was a requirement in the approval process. And that potassium is a nutrient that will be bound up in the soil and will be taken up by the trees anyway. Potassium limitation is a bit also of an issue. Have I got? Okay.
Yeah.
So we've been adding it on top of the leaves, as you saw in those photographs. And that's just kind of not really planned. And you can still see it there in the spring. So it is leaching out slowly, but then you can't see it there the next year.
Gotcha. That's interesting because another person asked if climate change and changes in hydrology will have an impact on how we might implement ash longer term. But you sort of spoke to that idea of pulses and.
I believe that ash additions can actually help deal with some of the issues of climate change. You know, one of the problems here is we only can remember and react to what we know. And all of us have been working during a time where the entire landscape has been affected by acid rain. So they were shocked in that experiment in Hubbard Brook when the stream dried up. It never occurred to them that there would be a link between calcium sufficiency in the forest and transpiration rate of the trees. So what we're seeing in the landscape now with spring floods and with wood production and greenhouse gas capture by the forest is biased by the fact that, at least for the mixed hardwood forests, they're all under stress, and they've been under stress from calcium decline as long as we've been working on them. And if you do some quick calculations with the size of the mixed hardwood forest of Eastern Canada, all of which is in areas pretty well that suffered from acid rain, and in every one of those areas, if we had a 30-year plan to add wood ash and get rid of the calcium decline problem, we could capture half as much carbon as the entire 2 billion trees program. If you work out the statistics, we should be doing more than planting trees. We should be making the forest that we have standing there as healthy as possible, as healthy as they were before acid rain.
That's amazing. Okay, well, before we leave the ash, an interesting kind of practical question about human burned ash. If you leave the bark on your wood before you burn it, is it going to be a better calcium source?
Absolutely. Most of the calcium is actually in the bark and in the twigs, especially of hardwoods. So, and if you're logging, you know, or if you're cutting from your own woodlot, put the ash, cool the ash for heaven's sakes, so you don't start any fires, and then either take the bark back to the forest, the twigs back to the forest, to leave it there, or take the ash back. If it's a maple bush, because that's the kind of bush that needs it most. If you're on thick soils, everything's probably okay. And if we could ever get an ash collection and spreading program started in Sudbury, then I would encourage you to share the ash with whoever is collecting that ash locally.
So people are probably going to get pretty enthusiastic about this idea now. If someone wants to, you know, try to improve the soils in their own backyard, is there any risk in terms of spreading ash themselves, especially if they live on lakefront properties?
I hope people get enthusiastic about this. People do many. I'll just tell you that we worked with an environmental psychologist in this program, and we've learned a lot from her. It's his postdoctoral fellow Layla that's the one that's working with us. And I assumed that the real psychological impediment to having people share ash with us would be logistical ones. It's too far, the ash drive was on the wrong day, I had to go to work, you know, all that kind of stuff. But that really wasn't it. The main impediment to people sharing their ash with us is that they had other uses for it. A lot of people were using the ash on their own property, or they were using their ash in their driveway instead of salt. Some people even were making soap. Like people were doing lots of things with their ash. So I wouldn't recommend putting it on the ice. A lot of people historically just have spread their ash out on the ice in the winter. So first of all, it's illegal. The ministry would actually consider that putting a hazardous waste directly in the water, even though that's what people have done for centuries. It makes sense to me to fix the land and fix the forest and let the land and the forest look after the lakes. So if we could get the calcium levels in the forest back up where it was historically, then there'll be enough extra calcium that'll flow through the pore water and into the lakes, and the lakes will be okay on their own. We should be protecting the entire watershed. And then let the watershed protect our lakes for us. You know, Bree, I've often said that if we protect the trees and protect the Daphnia, they'll look after everything for us.
I believe it. There's a linked question, and I don't know if it's a bit early to tell, but have we had demonstrations now where doing ash ameliorations have actually led to an improvement in calcium in lakes?
If it would be anywhere, it would be in Sweden. There's obviously lots of demonstrations of adding limestone, you know, to improve calcium levels in lakes. It's in Scandinavia where it's now mandated, it's required that the last thing loggers do is they spread pelletized ash over the whole landscape that they've just logged. And that's because it's an area that, like Eastern Canada, has had decades of acid rain. The reason, by the way, ash would work so well here is, so the ash is not a complete fertilizer, right? It has the calcium, it has the potassium, as I've said lots, and it has phosphorus, but it has no nitrogen. So all the nitrogen is burnt off in the fireplace or in the wood boiler. But here we have a great lucky accident, which is that there's been so much deposition of acid nitrates on the landscape in eastern North America that the soil is approaching saturation with nitrogen anyway. In fact, there's too much nitrogen in the soil for our forests. So adding a nitrogen poor but calcium rich fertilizer is actually a very good thing and actually corrects some real nutritional deficiencies in the soil. What Sean Watma's work would suggest with phosphorus is that if you add ash or any fertilizer from that standpoint to a soil that's hydrologically connected at some time of the year to a watercourse, those minerals will end up in the watercourse. So if the water levels rise enough in the spring, or if there's pooled water in an area that you've ashed, then the calcium will get into that pooled water and flow downstream into the lakes.
Awesome. Okay, I want to stay in the water for a little bit longer. So actually, Richard sent us a question. Daphnia or water fleas are essential in the food web. So if calcium continues to decline, what will be the result?
So when the calcium level in Plastic Lake, worked on by the Dorsey Ramos Science Center, fell to 1.5 milligrams per liter, we lost 6 species of Daphnia overnight, and they haven't come back. And so there's a sharp threshold for 3/4 of the Daphnia species. There are 2 other species. We have 8 Daphnia species. There are 2 others that are a little more tolerant of low calcium, but they slowly disappear. So what happens is that other species that require much less calcium can explode to fill that niche. And Bree, you'll know we have one of those species. It's called Holopenium, that lives in a ball of jelly. And those of us that have worked in this field, I don't know whether John Small is on the call or not, but we've actually called this in one paper the jellification of lakes. So there are 2 things going on: a combination of calcium decline on the one hand, and believe it or not, the spread of a zooplankton predator called the spiny water flea. Those 2 changes happening in our lakes are leading to the dramatic increase in abundance of jelly-clad species that can clog water intakes, that are less nutritious for the food web. So those are actually quite functionally significant changes that are happening in offshore food webs related to calcium decline and the spread of that invader.
Here's an interesting one. Is there a relationship between low calcium and incidences of blue-green algae, or increased incidences of blue-green?
Boy, that's a good question. I don't think it's been demonstrated by anybody. There is one demonstration from the paleontological literature showing that the reduction in the abundance of the algal grazers associated with calcium decline can lead to algal blooms or larger algal populations in one lake in the Maritimes. But not necessarily to blue-green algal blooms, to my knowledge.
Okay, I think I better go back up in the questions a bit and go back to the land. There were some interesting ones about forest management practices and forest fires or suppression of forest fires on carbon or calcium cycling in soils. So do we know anything about the interaction between more fires or different practices and what's happening in our soils?
Okay, a few things. There's a growing realization in the forest management community that preventing fires has been a bad thing for forest health over the long term, because our forests are evolved to naturally burn over every 30 years or so in Canada. And so I have been asked, and then there's bursts of growth in the forest, right, after there's a fire. So is that because there's actually more calcium? So this is not a solution, having more fires, because that doesn't replace the calcium that's actually been lost to that watershed. We need a new source. If a fire somehow allowed the rocks to break down faster or something like that, it would, but I don't think there's any evidence of that. I'll tell you, early on in the Ash Muskoka project, when we were dreaming big, one of our crazy ideas was to design an app for everyone's smartphone that would allow, we would have a big map that showed all the areas of the forest that needed the most ash across all of Muskoka. People would download this app, and then they could take their ashes out into the forest and add their ashes to the places that we had said needed the most. We would get the data. We would know where people were adding ash. It all kind of made sense to us until we thought of the fire risk. And then we realized it was one of the stupidest ideas I'd ever had. So
I don't think anyone would fault you for the thought. Okay, so we have some other questions about the ash itself. I think maybe particularly around Sudbury, the idea that ash might be contaminated by metals or could be a source of metals would be a concern. Is it possible to remove metals for ash or treat ash if it's locally sourced before it was applied? And would that be doable?
Well, that's interesting. Yeah, so you'd have to actually measure. So a couple of things. One way to reduce the level of metals in the ash, believe it or not, is to think about the trees that you're actually, or the source of the ash, the trees. For some odd reason, yellow birch has higher metal levels than sugar maple, especially cadmium, like much higher levels of some metals than others. So one option is to think a little bit about the kind of wood that you're burning. But there's no doubt that you'd have to initially measure the metal levels in the ash and evaluate whether there's a problem or not. I think Nate may have done that, but I suspect he hasn't done it for residential wood ash collected in Sudbury. You probably could, to some extent, control or remove metals from the ash, but that's kind of an industrial chemistry question, and I haven't thought about it very much. But you know, one thing industrial chemists are great at is getting the products they want out of raw materials. And so this is a situation, and they're particularly good at getting metals out of raw materials in Sudbury. So that if you could get the metals out of the ash, you might actually have a product there that you could market.
There we go. That's our next project. Do we have to keep adding ash forever and ever? When or will forest soils be able to reach an equilibrium and we won't have to help out anymore?
So the good thing is that they're always in flux. You know, remember that there's always dust and stuff coming in. You know, the most dramatic example is the Amazon rainforest that's constantly fueled by dust coming from the Sahara Desert. The Amazon forests are constantly being renewed by cross-Atlantic dust storms. I think what we have to do is be patient. It took probably 75 years for this problem to be created. I think personally, we only have to do it once. And that would fix things for 75 years. And if you add even a little more than that, it might fix things for longer. So it's not like once you get the calcium back to that spot on the landscape, let's remember that the trees have been growing there since the retreat of the glaciers. So for 10,000 years, no one was adding ash to the landscape because all of these nutrients were being recycled to some extent at a rate that permitted the forest to grow. Then we came along, and in 75 years, we stripped out more calcium than the previous 10,000 years had done. So if we just fix that immediate problem, we're probably going to be okay.
That's a great answer. This is a really interesting question that I had never thought of in all of my chit chats with you about this. Does the application of ash have an immediate or near-term effect on the biota of the soil itself? Like, does being covered in ash kill invertebrates or hurt microbes or anything sort of as it interacts there?
It absolutely could. I've been trying to find a forest insect person to work with us in the project and haven't found one yet. There's a chap who works down in the Halliburton Forest who's worked on the effects of ash on earthworms, on the behavior of earthworms and the abundance of earthworms. So they're absolute. Oh, okay. This has been studied with the calcium addition at Hubbard Brook. And I think it was net benefit, especially for snails, that there was a dramatic increase in the abundance of snails. And the result of that is that birds came back because they had a calcium source for their eggs. So there was a whole chain of connections that were beneficial. But in the short term, if the insect fauna that's there is used, has got used to soil that has a pH of 3.5 or 4, taking that pH rapidly up to 6.5, I'm sure will be harmful to some of the fauna that's there. But that's a pollution adapted fauna, and it would be nice to get back to an unpolluted adapted fauna.
This is kind of connected. Prior to acidification, what nutrient typically limited forest growth? Was it nitrogen then?
I think it was nitrogen. Here, this is a zooplankton ecologist trying to answer the question. I think historically the assumption is that our forests have been nitrogen limited, but it's complicated. The seedlings in the forest floor are for sure light limited, not limited by any nutrient. Or they can be moisture limited, but I think the chemical that most commonly limited forest growth was nitrogen, and it'll also vary from species to species. But in the mixed hardwood forests, the proof that it's calcium limitation is the dramatic changes when calcium was added, that the whole forest woke up.
Has calcium decline or sort of acidification of soils and calcium increased the dominance of conifers? There's a question about, does it lead to monocultures, or does it reduce deciduous forest, or was that really more just about the immediate effects of acidification on plants?
That's actually a great question, and I don't know the answer to it.
That's okay.
My gut feeling, I'm just thinking about competition generally, as the maple die, when the forest soils really are depleted with calcium, there will be something else step in. Like you saw how much lower the calcium requirements were of the birch than of the maple. So my gut feeling is that you'd end up with birch dominated forests. There's lots of studies going on right now about the competition between beech and maple, because they often share stands. And then, of course, what's happening now is the beech are dying out from parasite. And so that's mainly been the thrust of the work rather than what's happening with calcium.
Okay, that's interesting, because that was actually my next question. Somebody asked about the death of beech trees. Go on. My next question was about beech trees and wondering if it had something to do with calcium. So you beat into it.
There's actually a big study going on right now, funded by, I think, NRCan, that's actually looking at the effects of ash additions on the competition of beech and maple um, just on the outskirts of Algonquin Park, northeast of here. And the real interest there is what kind of happens when beech die. Because, you know, when you walk in a sugar bush or in a maple forest, you'll often see it's almost a monoculture of maple. You know, the whole forest floor is covered in little tiny maples that are 6 inches tall that might be years old, and they're just waiting for a canopy gap to explode up. So I think it's the competition between maple and beech could, I think, easily be influenced by calcium availability. And that's something we should be able to get a bit of a handle on now that we've added ash to a natural forest. The forest that we added the ash to in these much larger plots at 6 tons per hectare. The graduate students from Trent are looking at the maple, the beech, and the hemlock in those plots. Those are the dominant trees. So that we should learn something there.
Awesome. Hopefully I'm doing an okay job jumping around. I'm trying to weed through to the last remaining questions. This takes us back a little bit, but if there are major initiatives to plant trees as a climate change solution, how long will it take for it to have a positive calcium effect on forests?
Will the planting of trees have a positive effect on forests?
And calcium.
Pardon? Yeah, I don't think so. I'm trying to think why it would. So first of all, most of the trees that are being planted probably south of the forest that need the most calcium, because those are the areas that have been most extensively logged. The only reason I can think that planting a tree might help calcium is it might lead to a little more capture of dust if it slows wind speeds, and maybe mycorrhiza. There might be some possibility that mycorrhizae associated with roots might enhance the breakdown of minerals in the soil a little bit. So there might be, but that is all with the 2 billion trees program going to be happening in areas that aren't calcium limited now. I'm hoping that we can influence the 2 billion trees program to step back a little bit and not just use planting trees as a goal, but to use carbon capture by trees as a goal. And that means plant trees where there's lots of room to plant trees, but make the forest healthy by getting rid of the calcium limitation problem and thus increasing carbon capture in the mixed hardwood forest, where that would be the best way to increase carbon capture, is to get rid of the calcium problem.
I love it. This is an interesting one. Are there safeguards in the program to prevent possible propagation of invasive species, be they plants or insects, that might accidentally move around with the ash?
The only thing I've seen in the ash so far that came out of a bucket was a dead mouse. I have absolutely no idea how it got there. So let me tell you a little bit more about how we treat the ash. And just to suggest, I don't think this is an issue. To date, the ash comes in to us in those garbage cans. We screen it all through a fine mesh, run big magnets over it all, just to make sure that we don't have too much construction waste. We tell everyone not to give us any ash that's come from burning construction waste, but so far I'd say we've got a garbage can full of nails and screws and staples and lots of that kind of stuff. We don't want to add that to the forest. Then we homogenize it all and seal it in plastic drums. I don't think, and we only use the mineral ash, the fine gray fly ash. We're not sure yet what to do with the more carboniferous, charcoal-y type stuff in the ash. We're still measuring its chemistry, and it's about 10% of the weight of the ash, but we haven't been adding it. We've just been landfilling that stuff. So I don't think I've seen a seed. I don't think I've seen a branch, and only one dead mouse. in all the ash that we've added. So I think we're okay on that side of things. Now, the people that are tromping around in the forest and driving to the forest where we're adding the ash are probably a bigger risk. You know, I'm introducing seeds from the cuffs of their pants and that kind of thing, not the ash itself.
There you go. Okay, I'm gonna jump again a little bit.
This is fun, Bree.
This is fun. We should be at a restaurant or something, but I have heard that wood ash can also be used as a de-icer, making it an environmentally friendly alternative to road salt. And we know that we also like to talk about road salt. Is that a good idea? Is that, you know, just some of the other concerns that you raised about ash?
You can do whatever you want with your ash on your own property, first of all. And I have had 3 people of the 700, or no, we've actually interacted with probably 2,000 people one way or another. And 3 of them have said they can't have their ash because they use it as a de-icer on their driveway. And it works, as far as they're concerned, better than road salt. So I'll tell you that a lot of people must be doing things like that because calcium levels have fallen in the undeveloped part of our watershed and lakes, but they have not fallen in the developed part of the watershed. So in Lake Muskoka, for example, that's downstream of 1,600 lakes, probably 300 of which are developed, where people are doing all kinds of things with their wood ashes and doing other things with fertilizer. There has been no reduction in the calcium levels in Lake Muskoka, even though calcium levels in the rain have fallen. So there has been a reduction in calcium and natural calcium inputs in the lower part of the watershed that shows up in the Dorset Lakes as a 30% calcium decline. But there's been no reduction in the developed part of the watershed, which means a lot of people are adding, there's enough calcium being added by people to make up for the natural decline in calcium from the atmosphere.
That's awesome. Okay, so I think I'm gonna probably choose a couple more questions and we'll start to wrap up. I think we'd like to talk a little bit more about people getting involved. And so I guess one person was wondering, you know, if they want to know if their soil is contributing to a calcium decline issue or is poor in calcium, can they get it tested somewhere? Is that something that we should be trying to do in more places?
Yeah, I think it makes sense to try. I bet you Graham Spear, if this question is coming from the Sudbury area, Graham would know a lot about calcium levels in the soil. So it could be that wherever this person is, it's already been assessed. If it's thin soils under sugar maple, then chances are that soil could use more calcium. If it's thick soils in a valley, it probably doesn't. You know, it's probably okay. In terms of getting involved with the program, for the, I think it was 40% of people that are calling in from south of Sudbury, if they go to ashmuskoka at fotmw.org, if they're anywhere in this area, we'll take their ash. I'll tell you that we have one person who drives 6 hours from Manitoulin and gives us a 45-gallon drum of ash every year. We meet him at the Tim's in Huntsville and pick up his ash. It's Mike Whittle, formerly of Algonquin Park. So some people are really committed to this idea and are willing to share what we hope will become a valuable commodity, not just with us. We're doing it in the Muskoka area, but we hope other regions, Haliburton, Muskoka, Nipissing, Parry Sound, Sudbury, that have similar problems might develop their own programs. And our intent is to produce a how-to manual at the end of this with every step laid out, including the approval process, which has been pretty, the MOE has been very supportive, but it's awkward for them because they had no approval mechanism for wood ash per se, which we think of as a fertilizer and a good thing. but the MECP has no choice but to treat it as a potentially hazardous waste, you know?
Yeah.
So by the end of this year, we're in the last year of the Ash Muskoka project. One of the products will be a how-to manual laying out all the steps of establishing your own wood ash recycling effort in your own community.
Awesome. Just because you mentioned Manitoulin really quickly, someone was wondering if calcium decline is as much of an issue in forest soils and in lakes on Manitoulin.
No, but it'll be place specific. There's much less acid input on Manitoulin than in Muskoka or in Sudbury. And there's also lots of limestone in Manitoulin, but there's also quartzite in Manitoulin. So areas sitting on top of quartzite with thin soils may very well have this calcium decline problem on Manitoulin.
Okay. I think, and I hope that we've covered all of the themes and most people's questions got answered. So we'll save all the questions and make sure that they make their way to the speakers if we did miss any at the end. But I think at this point, I can turn it back over to Richard to close us off.
Thanks, Bree. It was a great interaction.
It was awesome.
Well, just a second. Oh, Dr. Yan, I found that a very interesting, an interesting presentation, and especially the questions that people were asking. I thought that was really sort of expanded what you had to say and provided a lot of pretty interesting responses. But I'd like to thank all the people who contributed to this webinar, the audience for their questions, those working behind the scenes tonight from FOCA, Terry Rees, and in particular, Michelle Levin, who manages the Zoom webinar system and in the background keeps everything running smoothly. Bree Edwards from Valley Living with Lake Center, and our speaker for this evening, Dr. Norman Yan. It's really encouraging to see a local group responding positively to environmental change and helping to maintain the supply of maple syrup. I'm glad that I'll still have that option to put on my pancakes for the foreseeable future. For those of you, when you leave the webinar tonight, you should be linked to a survey. We hope we've got that working properly, and we welcome any feedback that you can provide about this presentation. Next week at this time, Dr. Sapna Sharma will present On Thin Ice, Our Lakes Feeling the Heat. Using human observations that span centuries, she will show how climate has changed and in turn, how changing climate may affect lakes around the world. Stay safe by following the COVID regulations in your area, and good night. Thanks for coming.